So in this exercise, as discussed, we are having a biasing of 15 Hertz and we are using full voltage range 0 to 10 volt. Alright, so at 10 volt we will reach 50 Hertz, not at 7 or 8 volts. So this is the bias adjustment. Now this adjustment is called potentiometer frequency gain. Now if you know a bit of mathematical skills, if you are increasing 5 Hertz at every 1 volt, we may not achieve this curve. This will be like this. Okay, but if we reduce the number of jump in Hertz at every voltage, we may reach this curve. So we have to reduce the potentiometer frequency gain, which in this case is 70%. I'll be telling you how we get to 70%, and bias adjustment proportionally will change as well. So to have these values, we have the standardized formulas which the manufacturer provides. This says bias adjustments is equivalent to a constant XV divided by full voltage range into 100. So what is this constant? Constant is when you extend this curve at this quadrant, you'll get a voltage. Alright, so how to get this voltage? There is a formula for that. This is the formula to calculate XV, which says full frequency range. The full frequency range is 50 Hertz. So let me put here 50 minus bias frequency range. What we need is 15 Hertz. So you can put here 15 divided by full voltage range is 0 to 10 volt. So voltage range is 10. It's equivalent to bias frequency minus 0. Bias frequency is 15 minus 0 is again 15. So that will be 15 divided by XV. So this is 50 minus 30. 15 is 35 divided by 10 is 3.5. 3.5 is equivalent to 15 by XV. So XV is your 15 divided by 3.5, which comes out to be 4.28 approximately. Alright, so that's how you calculated XV. So this 4.28 is here. This is written in minus because this is in this quadrant. Now if you put 4.28 here, XV, you can do the calculations, divided by full voltage range, which is again 10 volt, into 100, so that is 42.85, because there might be friction here. Alright, so this is the bias adjustment we got here. So let me put this 48. In 48 I'm going to put 42.85. This is parameter 48, which was earlier 20%. I'm increasing that to 42.85. Yeah, 42.8 is fine. Alright, so this was the just bias adjustment. Now potentiometer frequency gain says full voltage range, which is 10 volt again, divided by a full voltage plus XV. So this XV factor is included in that, which is 14.28. 10 divided by 14.28 into 100, that accounts to be 70% approximately. So potentiometer frequency gain is parameter 50. We have to put 70% here. Oops. Yeah, now it's 70%. Okay, now let's see the response of our drive. This is the frequency. Right now it's 50 Hertz. Voltage is 10 volts. So if I go back to 0 volt, frequency, you can see it's almost 15 Hertz. Alright, if I go to K1000, just 2.5 volts, you have proportional frequency, and at 5 volt, which is K2000, 32.7. Earlier we were getting 10 volts 50 Hertz at 3200. Now it won't be there. So the whole voltage range is proportional. You can see that. If I put 3800, which is not equivalent to 10 volts, you have 48.4. So add exactly 4000 bits, or you can say exactly 10 volt, you have 50 Hertz. So this curve has been achieved. Alright, starting from 15, ending in 50. So the range is 15 to 50 of 0 to 10 volt. And that you can also configure not only with card but with potentiometer as well. That was adjusting the bias and adjusting the potentiometer frequency gain together, which makes this formulas. Alright, so that was all about biasing in VFD. Let's see what more we have in biasing.